So, hey everyone, thanks for coming. In this talk, in about 25 minutes, I'm going to present you how you can easily perform effective command section attacks like a colleague type. So, a few things about me. I'm Anastasios, this is my legal handle. Currently, I'm a PhD candidate at the University of Piraeus in the Department of Digital Systems. I'm also a member of Systems Security and Authority at the same department. And in general, I'm a builder and breaker. So, I know that many of you know what's a command section attack, right? Okay. For those who don't, I would like to mention that according to the OWASP, command section is an attack in which the goal is the execution of arbitrary commands on a host operating system with vulnerable application. And this attack is possible when an application, let's say a web-based application, passes unsafe user-supplied data, such as phones, cookies, HTTP, etc., to the system itself. And I would like to note here that the attacker's applied operating system commands, the arbitrary operating system commands, are usually executed with the same permissions and privileges of the vulnerable application. So, the main target of command section attacks is the Internet of Things, or the Internet of Things. The main reason for that is because command section attacks are operating system independent, as well as programming language dependent. But let's see what causes command section flaws. The main reason that the application is vulnerable to command section attacks is due to incorrect or complete lack of input data validation. For example, the following piece of code gets an IP address through the getADR parameter, and after that, the ping command here is executed over the provided IP address, and the result of the execution is echoed in the script. As you can see here, there is not any input data validation, which means that if someone puts a separator, let's say the semicolon separator, and after that another operating system command, such as the ls command, both of them, the ls command and the ping command, will be executed the one after the other, exactly like the following system said, right? So, during that research, two main categories of command section attacks were identified. The first one includes results-based command sections, in which the vulnerable application just outputs the result of the injected command, and the attacker can directly infer if the command section succeeded or not. And of course, the injection results are visible. The second category includes blind command sections, in which the vulnerable application just does not output the result of the injected command. And even if the attacker injects an arbitrary command to the vulnerable application, the results will not be shown in the screen, so the injection results will not be visible. Let's see these attacks in detail. So, the first one is exactly the same example as previously mentioned. Here is the vulnerable part, and if someone puts an IP address, or if someone puts an IP address, then a separator, and then another operating system command. In both cases, the execution results will be visible. Let's take a look at the blind case. As we can see here, there is not any echo at the start in the beginning of the line. The vulnerable part is the same. So if someone puts just the IP address, or if someone puts an IP address which is followed by a separator and then another arbitrary command, in both cases the execution results will not be visible, right? So, in order to see, we have to be blind. The first technique that I would like to show you is a completely blind technique. Is the time-based blind technique, which is based on time delays. The attacker can presume the result of the injected command. Firstly, it's decided if the application is vulnerable to time-based blind command sections or not. For example, this payload is a Unix-based payload. A randomly selected 6-character string is echoed, and if the length of that string is found to be 6, then it sleeps for 1 second. Then the length of the output of the provided inject command is determined exactly the same way as previously mentioned here. It's exactly the same payload. And finally, the output of the injected command is exported chart by chart, right? Exactly like an SQL injection. blindness factors. The second technique that I would like to introduce you is not a completely blind technique, it's, let's say, a semi-blind technique. This technique is the file-based semi-blind technique, which is based on the fact which claims that if we're not able to see the results of the execution directly through the vulnerable application, we can write them to a file in web server's directory, which is writable or accessible by us. Right? So, I know that this is a pretty straightforward way in order to exploit a blind command injection. Here, a randomly selected string is echoed into this file. Right? The problem here is that what I told you that the web server directories are not writable. We can use temporary directories such as TMP, RTMP, etc. in order to store a file with the output of the inject command. The problem here is that we cannot read files located into these temporary directories through the web application because of, let's say, the blindness of the vulnerability. So, in order to bypass that limitation, a new and undocumented technique, the temp file-based technique, was developed and implemented. Designed and implemented. This technique applies the file-based technique in order to store the result of the injection into these directories in combination with the time-based technique. So in that way, the contents of the files which are located into these temporary directories will be extracted out chart by chart. Right? So, the comics tool, how many of you know what is the comics tool? Okay. Comics is a short for command injection exploiter. It's a software tool that can be used in order to find and exploit command injection flows in web apps. It's available at GitHub. It's written in Python. It's a cross-platform app. It's a free and open source, and the license is under GNU GPL version 3. If you want to get the latest version of comics, you can use the official Git repository. Or if you are using one of the following penetration testing Linux distributions, you can use the official package manager in order to install or to update. I would like to note here that comics comes pre-installed in Kali Linux. Or if you are using one of the following penetration testing frameworks, in which comics comes as a plugin, you can use the corresponding option in order to update or install it. Okay. Comics supports many exploitation techniques. Regarding results-based command injections, the classic result-based technique is supported. This technique is based on just the execution result output. It also supports the dynamic code evaluation technique, aka the eval-based technique. This technique is based on the eval's execution results, but except for result, also the preg replace, the user, the assert, the st replace, and the preg match injections are also supported. Regarding blind command injections, of course the time-based blind command injection is supported. The file-based semi-blind injection is supported also, and of course the combination of these techniques, the temp file-based. Okay. I would like to note that all the described exploitation techniques provide many variations of attack vectors, which are specially adjusted for the target host. Let's say for Unix targets, the attack vectors are based in a single or a combination of bash commands. And for Windows targets, the attack vectors are based on a single or combination of CMD and or PowerShell.exe commands. In order to reduce false positives, and regarding results-based command injection, a randomly generated 6-character string is printed 3 times in combination with the result of a mathematical calculation of 2 randomly selected numbers, something like this payload, and from this payload we must take as a response the union of these strings combined with the result of the mathematical calculation, something like this value. Regarding blind command injections, the problem here is the high probability of false positive due to unstable requests. So, the average response time of the target host is calculated and also a time-relative false positive identifier is used. This average response time is added to the default delay time, which is used in order to perform time-relative attacks, such as time-based and temp-file-based attacks. And the time-relative false positive identifier, which detects unexpected time delays due to unstable requests, uses statistical analysis in order to detect the unstable requests. So let's see some basic functionality of comics. For HTTP headers, we are able to provide, first of all, our own HTTP headers. For example, the user agent, the referer, cookie values, or extra HTTP headers, something like the following figure here. Or we can perform tests for command injections against the HTTP headers. Here is an example. And as you can see here, there is a command injection attack through the user agent HTTP header. Here is the payload. And if the value of the level option is greater or equal to 2, then automatically comics tests the cookie values. And if the level option is equals to 3, then it automatically tests user agent and referer, right? In order to enumerate target hosts, we are able to use the enumeration options. Through these options, we can retrieve custom username, current username, current hostname, to check if current username has root privileges or administrator privileges. We can retrieve system information such as operating system, hardware platform, etc. We can retrieve system users list, system user privileges, password hashes. The only limitation here is that this sample file must be readable by the current user. And if we are against a Windows target, we can retrieve a PowerShell's version number. And if someone puts all these flags together, or if someone puts just the sort option, the result will be similar to this figure. An alternative operating system shell. Through that shell, we are able to bypass target host bus limitations. There could be restrictions of bus commands, let's say the cat, the echo, etc. At this moment, only a Python alternative is fully supported on every described technique, but my future plan is to support PHP, Perl, Ruby, etc. alternative operating system shells. Here is the alternative operating system shell of Python, and as you can see here, the payload has turned into Python. Comics is able to bypass mod security's default block attempt rule. This rule blocks the pipe symbol, command substitutions, parameter expansions, and matches duplicate kernel CC, which, as the author claims, are often used in order to perform injection attacks. But as you can see here, the payload has properly transformed into this form in order to bypass mod security's block attempt. We really love shells. That's why Comic supports netcat reversals, netcat without netcat reversals. For more, please take a look at the user's example wiki page, in which several test cases and attack scenarios are supported. We can write or upload our own web shells on target through the file access options. We can upload our own PHP interpreter shell or Willy, I don't know. Please take a look at the upload shells wiki page for more. And here are some shells in action. Here is the netcat reverse shell. Here is a PHP interpreter reverse shell for Windows. A Linux interpreter reverse shell through the Armitage. Comics is also modular, which means that in order to increase the capabilities of Comics and to adapt it to our needs, we are able to develop and easily import our own modules. For more, please take a look at the module development wiki page. By default, three main modules are supported: the ISMP exfiltration module, the DNS exfiltration module, and of course the shellswap module. And here's the shellswap module in action. In order to evaluate comics, I used many vulnerable web applications. The last one is the official comics testbed, which includes many vulnerable application into command injection attacks. I think we have time to say a demo. Here's the comics testbed. We use that just to make the others to test. This is the URL. We're going to put the URL into comics. And after that, I'm going to use more options in order to enumerate the target host. Hostname, the current user, and the system info. The enumeration options, the payload. Here is the pseudo terminal shell. All right. We can use the option reverse TCP shell in order to launch a reverse TCP. DL port, DL host. Okay, here's another handler. Here, interpreter PHP. Yeah. Okay. The next one is for Windows. I want to show you the blind section. So let's take a look at the blind case. I'm going to use the time-based technique and the file-based technique for that. And this is the remote mode. In order to see payloads, here are some payloads, and this is the payload that determines if that application is vulnerable or not. I'm going to execute the uname command, retrieve 5 characters, and trying to export the result of that. This is Linux. I'm going to try the file-based technique. In here, the payload. Okay, this is the result of this execution. I don't know, have we got any time?
Yeah.
Let's see some other injections. The user agent is the injection.
Yeah, 20.
Oh. the cross parameter here. And I'm going to try to exploit the user agent of that scenario. The technique is the classic result base. As you can see here, the level is 3. In order to perform a test for user agent referrer, okay, this is the payload. Exactly the same with the reference header. Okay, the same thing. Technique is the same. You can specify which technique you want to use. Okay, again the level is 3. This is the third level. Here is the payload again for the referrer. Okay. Here's the sensor module. You can specify the dust sensor flag. This is a reverse TCP set again. I'm going to use netcat reversal for this example. This is for BSides. Okay. All right. If you have any issue, you can open it at the GitHub. That's all. Questions?
What if your target URL is more than one parameters? You
Yes.
try one of them serially.
Yes, or you can specify which one you want to check.
Okay, the second question. Initially, you don't know what operating system your target has. So do you try all the different payloads of the Linux or Windows?
No, by default, uses some heuristics in order to understand the target code. If it doesn't, it tries to ask you to tell if it's Windows or Linux. If it's not, it not proceeds with the exploitation if you not specify which one.
What kind of heuristics do you mean? Like if it specifies from the headers or something?
Yes, for headers, for server ID, something like that. It's for web apps.